Okay, so we have two more sections in this general deductive reasoning module. The next one is validity. Okay, so we're looking at a little graph that tells us how routes can be between San Antonio, Lubbock, Austin, Houston, Dallas. You can see most of the arrows go both ways, some of them don't. You've got this one just goes one direction, this one, and that one. I guess most was a bit of an overestimate, but anyway, some of them go both ways, some of them don't. But you also have, this chart so that you can see, in fact, when they go from where to where. So the first one says, if Sally is traveling from Lubbock to Houston, leaving at 8, in what city will she have a layover? So let me get a pen here. She's going from Lubbock at 8. So if we look at 8 right here, this is the only flight. Oh, that's not very useful. Okay. This is the only flight from Lubbock at 8. So she must be there. So the question is, in what city will she have a layover? Well, Dallas, right? Because the only way to leave Lubbock at 8 is to go to Dallas. Let me switch pen color. Raul is leaving San Antonio to go to Dallas for a 1 o'clock business meeting. His secretary booked a flight through Houston. So the first thing is that he has to go from San Antonio to Houston. So we have this option, or this option, because that's the 2 times a day that happens. But you can't leave Houston again until the next day at almost the same time. So surely his secretary is not a complete imbecile. Surely she put him on this flight to Houston. If she did, then he can take Houston to Dallas here. Because see, he arrived at 9. So he can leave again at 11. And he'll get to Dallas at noon. And that is before 1. So yes, assuming non-imbecilic secretary, then yes. She tried to book the return route for the next day, but couldn't get the same route. Why not? So the same one in reverse order would be going from Dallas to Houston to San Antonio. If we look on this right-hand side on ways to get to San Antonio, or even if you just look at this chart, there's only one arrow that points to San Antonio, and that's from Lubbock. So let me switch again. So if I want to get to San Antonio, I have to go through Lubbock. And this did not go through Lubbock. So the reason she can't book the return route is in the same route is because you can't, there's no path from Houston to San Antonio. Okay, and the last one, Laura lives in San Antonio, and her best friend Sarah lives in Lubbock. Laura plans on taking a direct flight to go see Sarah. And Sarah tells Laura it's not possible. So what you'd have to have is a flight going straight from San Antonio to Lubbock. If you look on the left, San Antonio goes to Houston only. If you look on the chart, San Antonio only goes to Houston. There's no arrow this direction. So if Sarah wanted to go see Laura, she could go directly, but not the other way. Okay, so we're on the same chart. We just have a couple more questions. Lucas is planning to travel from Dallas to Austin today, going through Houston. Is this a valid travel plan? So he wants to go from Dallas to Houston to Austin. So Dallas to Houston is fine. It's right there. So Dallas to Houston. And then he wants to go from Houston to Austin. Well, there's a path right there, but look, they're at the same time. So he'd have to travel in time between Dallas and Houston to be able to then go on the same day, which he wants to do, from Houston to Austin. So really, he'd have to be at least here on Houston to Austin, but that's not even really realistic because you have to get from one plane to the other. So no path from Houston to Austin follows a path from Dallas to Houston. Okay, we want to create a route to get from Austin to Houston and write out each connection we'd have to make and see if there's another way we could do it. So from Austin to Houston, we have to start in Austin, so we have to go Austin to Lubbock. That's the only way. If you look over here, Austin only goes to Lubbock. The other one's space in. So we have to go to Lubbock. And then from Lubbock, we can go to Dallas, or we can go to San Antonio. If we do Austin to Lubbock at 6 a.m., then we can do Lubbock to Dallas or Lubbock to San Antonio. We have plenty of time. So we'll say that we go to Dallas. We get to Dallas at 9, and then we can leave Dallas and go to Houston at 10. Okay, so there's one. And that does it all in one day. And in fact, we could go from Austin to Lubbock this afternoon, but then would still be in the same situation as follow, but it would just be the next day because there are no more paths between 12 to 1 today and 6 to 7 tomorrow. So this would still look the same. Now, what if we had taken San Antonio instead? So let's say we went, this really goes down here. Let's say we went from Austin to Lubbock, again our only option, but Lubbock either goes to Dallas or San Antonio, so say it went to San Antonio. Then we would have gotten to San Antonio at 10, and we could have gone San Antonio to Houston at 11, so we could have gone this way. So it's not the only path, and I'm sorry to have blinded you with that color down there. Okay, we want to look at number 6, determine which of the following would be invalid. So valid means able to be verified, true. If lines are parallel, is it invalid to say they will never intersect? No, it is valid to say that they will never intersect. Because if they intersected in Euclidean geometry, which is what we're doing, then they would not have been parallel. Then the lines are coplanar. That may seem a bit confusing, but you actually have to be coplanar to be determined to be parallel. If you define it to just be parallel lines intersect, then you could really have perpendicular lines in different planes. So like put your arm out in front of you and put the other one perpendicular to it but under it, and they're in two different planes. They never intersect, but they're definitely not parallel. The planes are parallel. So they do have to be coplanar to be defined as parallel. Then the lines are skew. Okay, so if lines are skew, then that's what I just briefly described to you. If they're not parallel, but they never intersect, so like your arms would have been if you did what I said, which you probably didn't, and those are skew lines. But part of the definition of being skew is that they're not parallel. And then the lines contain no common points actually means precisely that they will never intersect. So the answer to the question is this one. Let me change that blinding color, shall I? Okay. If a triangle has two congruent sides, which of the following would be a valid conclusion? So congruent means they're the same length because a side is just a line segment, and for line segments to be congruent, it means that they're just the same length. So the options are: it is a scalene triangle, it is an isosceles triangle, it is an equilateral triangle, it is an acute triangle. Okay, so this time we're looking for a valid conclusion. We can't, it shouldn't be scalene. Scalene means not isosceles. So definitely not scalene. Scalene means that all three sides are different from each other. And this one has two that are the same. Isosceles means two sides are equal. So this is a valid conclusion here. Then it is equilateral. Well, it may be. So it's not scalene. It is isosceles. It may be equilateral if that third side is also congruent, but we can't know. Then it is acute. Again, maybe, because maybe it's like this. But it may also be like this. And we don't know. So this is not a valid conclusion, it's a possibility. Same thing with this. So this one is valid. Okay, so the following statements are true. Write the conclusion that logically follows. So here's an example. If a figure is a rectangle, then it has 4 right angles. Figure ABCD is a rectangle. Therefore, figure ABCD has 4 right angles. If an animal is a giraffe, then it is a mammal. Gerard is a giraffe, so Gerard is a mammal. If I go to a movie, I get popcorn. If I eat popcorn, then I get a drink. So from this, if I get popcorn, then I get a drink. Then we could say if I go to a movie, then I get a drink. This requires that I eat the popcorn. There's nothing I can necessarily draw from this unless I change this word to get. Because I might go to a movie and get popcorn and not eat it. It seems unlikely. But if I change this to get, then I have, if I go to a movie, I get a drink. Because going to a movie makes me get popcorn, and getting popcorn makes me get a drink. So going to a movie makes me get a drink. If it is snowing, then the temperature is less than or equal to 32 degrees Fahrenheit. If the temperature outside is 20 degrees Fahrenheit, I cannot make the conclusion that it is snowing. I have to know that it's snowing to know anything, because while it has to be freezing for it to snow, it doesn't snow every day, it freezes. A midpoint divides a segment into 2 congruent segments. So the definition of a midpoint is that it splits the thing in 2 equal pieces. M is the midpoint of AB, so I can assume that the line segment from A to M is congruent to the line segment from M to B. Okay, so I think this is the last one. This is just a little interesting thing to think about. And we have 4 cards with a letter on one side and, oops, that should say a number. Oh, let me get a pen first. This should say a number on the other side. The following statement describes the way the cards were made. If a card has a letter A on one side, then it has the number 2 on the other side. What would we have to pick up to decide if it was true? Well, the only things in play here are A and 2, right? But the hypothesis of the statement, if the card has a letter A on one side, then it has the number 2 on the other, is that it has the letter A. So in fact, you could have a 2 on the back of all the letters from A to J, and this would still be true. So we don't actually need to pick up that card with the number 2. We only need to pick up the card with the A, because if it has an A, then it has to have a 2. So we have to find something that makes the hypothesis true and check the conclusion. So the only one we'd have to pick up is this card here, and if it had a 2, then it would be true. So that takes us to the last set of things that we need to do for this module, and I will get that started shortly.